Finish up this here, and then get to the rest of things. So I like to define something which is called sequential compactness. So we define compactness. Define something which is sequential compactness. We see that the sequential compactness in case of R, in case of Rn is same as compactness. In general topological spaces, sequential compactness can be. What do you mean by sequential compactness? So definition is the subset. So in case of set of R is called sequentially compact. Not the book, is not defining it, not defining it. It's called sequentially compact. If every sequence xn in K as a convergent function. Subset is sequentially compact. If you pick a sequence from K, then the convergent subsequence
That's it.
in K. And claim is three parameters that if for K subset of R following direction is compact. This is sequentially compact. So it's in R, there's no difference between compactness and sequential compact. In other words, this definition also becomes a criteria of something to be compacted. Okay? You want to prove something to be compact, make a sequence in that set. If that sequence has a convergence of sequence in that state, it's like a sequentially compact, but similar to the compactness. So as I said, it's true in R, it's true in Rn, it's true in some mutual spaces. Purpose. It's not true in general. There can be topological spaces where compactness is there, don't have compactness. Okay? So how should we begin? Why? Just think about it for a moment. Why? This thing is really obviously follows. Think about it. That my claim is this: sequential compactness follows really trivially from compactness. Now I want to show that K is sequentially compact. What I need to do, I need to take a sequence from Excel. So let's take a sequence Excel. Okay. And I would like to show that this sequence must have a convergent subset. And in K actually. Okay. So what should I do? Why this sequence must have an equal? Obviously, our assumption about K is that K is a compact set. And you have this beautiful characterization of compactness, sense of elaboration. What does that says?
Then it is closed and closed.
We still need explanation that why it should have a convergent subsequence, because K is closed. Therefore, it should.
It contains its limit wise.
So first we need to show that it must have a convergent subsequence. Why does this obviously follows from? Because it is. If it is bounded, what's interesting about that? We have Bolzano versus there. He says that if you have a bounded sequence, okay, there must be. So in other words, if we say that K is bounded, then the sequence should be bounded as well. Okay. If the sequence is bounded, it must have a convergent subsequence. But that's not enough actually. We want that limit to be in K itself.
So it's case closed.
The closeness actually. We learned that if a set is closed, then it contains all of not only limit points but sequential limits as well. You take a sequence basically in it and its limit, if it is convergent, limit should also be bounded. So by Bolzano Webster's it implies that there exists X and K such that this X and K converge this way. We say that by reliable K is bounded plus closed. Just writing a rough sketch of it, we will try to write it here. Do for that. Okay. And with that, since it is bounded, the sequence must be bounded. When a set is bounded, all of elements are bounded by a number basically. Upper bound and lower bound. Okay. So if this is the case, then this sequence is also part of this. That boundedness property as well. Bolzano versus there that if you have a bounded sequence, it must convert in some sequence. Okay. And then from closeness of K is implied that X should also really happens. Because we have done a criteria sufficient condition for closed sets that if you take a sequence in a closed set, which is convergent, then the limit is also going to be. This part was very trivial. You think about it. Second. Why it's utilized? Why set is sequentially compact, it should have a compact, or should be compact. So whenever we think of compactness in R and Rn, always think it from perspective of closed and boundedness. Find definition always will not help sometimes, But this criteria that compact set must be closed and bounded is validation. Okay, so what you can think of is that okay, A is sequentially compact, and think about proving that A is closed and bounded. Like to do so. Why A should be? Let's begin with boundedness. Okay. Why it is bounded? Keep in view that boundedness means what? Means that there is an interval which contains your self. Suppose not. Suppose A is not bounded. So if it is not bounded, what does it mean?
That upper bound means what? I don't know how to do.
And so your upper bound, what do you mean by not having upper bound and lower bound?
Sir means
Yeah.
negative is directly.
Sequence that which is going to tell us. My point is that a set is not bounded. What does it mean? Just think about what is the definition of being bounded? So A is bounded
All of its points are.
if precision, if there exists another M that will positive, such that all of the elements in this M are is less than or equal to or all X in K active. What would be the negation of this M?
आप कोई पॉजिटिव नंबर उठा ले उसके लिए कोई एक ऐसा पॉइंट होगा जो उससे बड़ा हो जाएगा
That for all M positives, there is this fact such that X going to go beyond this time. We think that this is going to help. Think about, can I connect this with compactness? Can I construct a sequence using this number, which will not have a convergence of sequence? Hence, we will have a contradiction in sequential compactness.
So I didn't get the start of it, so I'm bounded there a few way. I didn't get the start. How did you start it? I'm bounded there a few way.
You can go to closeness, fine. Doesn't matter. Anyway, so I will say that for every n in set n, okay, if I treat that as a kind of a n, then there exists xn in K such that absolute of xn is bigger than m. In other words, no n can be treated as upper bound. So for every n you can find such kind of n. Okay?
Yes, sir.
Now, why this is a troublemaking statement? Now, as xn is a sequence in K, so by definition of sequential compactness, there exists X and K subsequence converted. Let's see.
Which is convergent LK.
Convergent. Right. Yeah, this be a convergent subsequence. Can this be we have this convergence. One of the obvious properties that since X and K is part of this sequence, it should have this property. This is should have this property. How you can have a sequence which is convergent and sound at the same time?
Yes, sir.
So if I say, just think about it. If I say X and K is convergent, so for this sequence there exists a subsequence which is convergent, and from this and from star, what does it show? That X and K is bigger than all and K. But if X and K is bigger than all and K, for all K, in the end, what you can immediately say about X and K? You're going to say it's not bounded actually. This implies X and K is not bounded. If it is not bounded, it can't be convergent. You just said that it is convergent. Yeah. X and K is not convergent. So what? First of all, that's a flat combination.
How would
Achieve that the location, otherwise you don't have to solve it. Let's think about closeness. Let's think about phase closeness. Is there any trouble in this basically? Okay. Why K should be closed actually? What do you need to do for proving something is closed?
limit for sub
Well, limit point should be.
limit for sub K R and D.
That's one of the way to do it. The other way should be that okay, take a sequence in it and show that it converges in.
Okay.
So like I said, a sequence. Okay. The convergent subset. Convergent sequence. Convergent होगा?
Yes, sir.
Such that it converges L and facility. I don't know that whether it is yeah. That's what I'm sure.
Yes, sir.
Now, why L should also be in A? And you have this definition of sequential compactness. So what we're gonna say that since this is a sequence, convert this to L. So that every subsequence is also going to converge to L.
Yes.
But we said that since you have sequential compactness, so that subsequence is converging to L, so this limit should be so by sequential compactness, like this, X and A. Realize. If this is then every
Yes. X7A.
okay, complete source okay, also converts to one. And by sequential compactness, this L this is the case.
So if a sequence is not bounded, if a sequence is not bounded, then it's every subsequence must not be bounded.
Sequence is not bounded. If a sequence is not bounded,
Every
then
subsequence.
you can have bounded.
But here we have that if a sequence,
But like
sequence is not bounded.
There exists a sequence.
no, the trouble is this that this is satisfied by the whole of sequence. Right? Even if you take the subsequence of 20, obviously this sequence, subsequence is an arbitrary subsequence. It should satisfy also the unbounded. Anyway, so that's my version of proof basically. You can also see a different version, a different arguments from different. Now just think about it. You know, what is the beauty behind this sequential compactness? Just see the definition again. Do you see anything interesting behind that? Yeah, what is the most interesting thing that you basically thought? You basically observed it. Please keep the level. Then we if the government relation this thing will say that both have covered. So for something to be compact, this tells us that you have now 3 ways to prove something to be compact. You have definition.
Oh,
You have enamorel theorem. And you have and you also have something to be non-compact. I mean, if you want to just think about it. If you want to prove something that is not compact, you can show that it's not bounded. Just so that it will not grow. Okay, in other words, you just take a sequence in it and just show that it's not converging in that. But can you see that how the definition of sequential compactness helps you to prove that something is not compact? No, I mean, obviously that's one of the ways to do it. But I'm saying that now you got another way basically to prove compactness or non-compactness of something. So you just need to do what you just need to show that you have a sequence, it does not have a convergence of sequence. Just show that. So sequential compactness says what? Is that every sequence has a convergent subsequence in K. Every sequence in K has a convergent subsequence in K. So you have two things actually. The first thing you can show that okay, doesn't have a convergent subsequence in first place actually. So if it has a convergent subsequence, then it just misses the limit, you are also done with it. Okay, is it making sense? Sequential compactness, something. There is another equivalent characterization of compactness, it is called the limit point compactness. And as I said again, probably you're going to see this in pathology, that for R this is same as compactness, sequential compactness, but in general pathology this is compactness. So what do you mean by limit point compactness? So K subset of R is limit point compact. Compact, then infinite every infinite subset of A, it has a limit point. That's what I'm going to compactness is that every infinite subset of A has a limit point again, but in A. Let's take okay. Not every subset, but my key claim here is that this limit point compactness is equivalent compactness. And hence to sequential compactness. All are equivalent. That's why this should be
The union of all those subsets.
next.
All those, take the union of all those infinite subsets of K. Then they will give us Q. All possible.
All possible.
Gives K for every
Extend the real.
Let's think about this side first. If you have compactness, why you should have limit point of compact?
Because it's bounded, the electric will be bounded,
Yeah.
and then it's I think case closed also. So the limit point update, subset will also contain its case.